Hi guys, welcome to you all. In this session, we will discuss about disaster management, chapter 2, part 1, that is earthquake. So these are the contents in disaster management. Right now we are dealing with chapter 2, part 1, that is earthquake. Let's start.
So what is an earthquake? It is the sudden shaking of the earth crust. The impact of an earthquake is sudden and there is hardly any warning, making it impossible to predict. So this is the most destructive natural hazard. They may occur at any time with sudden impact and less warning. They can destroy buildings and infrastructure in seconds, killing or injuring the inhabitants. Cause of earthquake. Inside the earth made of hot molten rock called mantle. The earth crust we live on float on top of this mantle. However, the earth crust is not a single solid land. In fact, it is broken in many pieces. These pieces are called tectonic plates, which vary in size from hundreds to thousands of kilometers. When these plates contact each other, stresses arises in the crust. These moments are associated with earthquakes. The area of stress at plate boundaries which releases accumulated energy by slipping or rupturing are known as faults. This fault rupture generates vibration called seismic waves which radiates from the focus in all directions. So, general characteristics of seismic waves. Seismic waves are two types. First one is body waves, the second one is surface waves. In body waves, they penetrate the body of the earth vibrating fast. P waves travels about 6 km per hour, whereas S wave travels with a speed of 4 km per hour. Whereas in surface waves, vibrate the ground horizontally and vertically. These long period waves cause swaying of tall buildings. So what is meant by swaying? So swaying means in normal conditions, our buildings stand like this. Due to these surface waves, our buildings deflects very small amount. So these type of deflection of any structure is called swaying. So these are the major tectonic plates. There are 7. So first one is Pacific plate, the second one is North American plate, South American plate, African plate, Eurasian plate, Indo-Australian plate, Antarctic plate. So there are 3 types of plate motions. The first one is divergent. So what is divergent plate motion? Let me put another color. So if we assume 2 plates like this, so this is one plate, this is another plate. They are moving away from each other. This type of plate motion is called divergent plate motion. The best example of divergent plate motion is mid-Atlantic ridge, which splits the entire Atlantic Ocean north to south. This is mid-Atlantic ridge. The second one is convergent. So what is convergent? The best example of convergent plate motion is Himalayas. But what is convergent plate motion? Let me explain in this slide. So let me take another pen. Then yeah, this color is open now. Yeah. So for example, the Eurasian plate is moving and dives on the Indian plate. So this is called convergent plate motion. Due to this, Himalayas are formed. So the next type is transformational plate motion. What is meant by this? So there are any two plates, they slides horizontally, like their directions will be like this or reverse in nature. The best example of transformational plate motion is the San Andreas fault slicing through the Carzo plain. So there are some technical terms, so I will explain in brief. Okay, so if we assume like this is one plane, one plate, this is another plate, this line is called fault line. So in this fault line, the stress is concentrated at one point. This is known as focus. The projected point on the ground surface is known as epicenter. The distance between focus and epicenter is known as focal depth. So these are the terms. So fault line, we know that this is fault line. Focus. So let me explain once. Okay. Yeah. So this is called fault line. The point at which stresses are concentrated is known as focus. The projection of focus on ground surface is known as epicenter. This is epicenter. The distance between focus and epicenter is known as focal depth, small f. So is it clear? Next slide. So there are three types of earthquakes based on the focal depth. First one is shallow focus earthquake. The focal depth is less than 60 kilometers. The second one is medium focus earthquake. The focal depth is 60 to 300 kilometers. The last one is deep focus earthquake. The focal depth is 300 to 700 kilometers. So this is very dangerous earthquake because of their proximity to surface, whereas in deep focus earthquakes are rarely destructive because by the time the waves reaches the surface, the impact reduces. So how to measure earthquake? The instrument used to measure earthquake is called seismograph. So there are two types of seismographs. The first one is Richter scale, then second one is modified Mercalli scale. So I will give you the basic idea of what is Richter scale and what is modified Mercalli scale. So Richter scale is measures only earthquake magnitude, whereas in modified Mercalli scale, it measures earthquake intensity. So this is very important. The values are ranging from 1 to 12. The magnitude of 3 is the smallest normally felt by humans. Intensity of 6 and below, most of the people can feel the shake. So there are four zones, four earthquake zones in India. So the zone one, first one is zone 2. It can be anywhere. Zone 3 is moderate risk zone. The Andaman and Nicobar Island part of moderate risk zone. In these locations like Andaman Nicobar Islands, parts of Kashmir, Western Himalayas, Andhra Pradesh, Chennai, Kolkata. So the third one is zone 4. It is high risk zone. In this are capital Delhi, Jammu and Kashmir, Patan area near the border of India and Nepal. The fifth zone is very high risk zone. Kashmir, the western and central Himalayas, north and middle Bihar, the northeast Indian region, and the run of Kutch. So distribution pattern of earthquakes in India. India falls quite prominently on the alpine Himalayan belt. What is it? So this belt is the line along which the Indian plate meets the Eurasian plate. You see in that slide, no? So this is Indian plate, and this is Eurasian plate. So this belt is the line along which the Indian plate meets the Eurasian plate. This being a convergent plate, the Indian plate is thrusting underneath the Eurasian plate at a speed of 5 cm per year. The moment gives rise to tremendous stress, which keeps accumulating in the rocks and is released from time to time in the form of earthquakes. So the next one is possible risk reduction measures. In this, first one is community preparedness. Community preparedness is vital for mitigating earthquake impact. The most effective way to save you, even in a slightest shaking, is drop, cover, and hold. The next one is public education. Educating the public on causes and characteristics of an earthquake and preparedness measures. It can be created through training programs for community architects, engineers, builders, masons, teachers, and students. The next one is engineered structures. Buildings need to be designed and constructed as per the building bylaws to withstand ground shaking. Architectural and engineering inputs need to be put together to improve building design and construction practice. So these are the significant earthquakes in India from 1950. In this, the most magnitude is in 1950 Arunachal Pradesh, China border with magnitude of 8.5, whereas at least there are two in 1991 Uttarkashi, Uttar Pradesh hills, magnitude of 6, and with magnitude 6, and other one is 1997 Jabalpur, Madhya Pradesh with magnitude of 6. With a magnitude of 6, but the largest earthquake that has been recorded with a magnitude of 9.25 in Alaska in 1969 and Chile in 1960.
Thank you guys for watching this video. Please comment if you have any suggestions. If you like this video, please give me a thumbs up, and for more videos please don't forget to subscribe. Thank you.